All right. First thing we talked about yesterday was this right up yonder. Owen, read that to me. How would I say that?
The third, bro, I forgot.
You're almost right, but bro is not part of it.
The third root of 8.
The third root of 8. What if there's a 7 right there? How would we say that?
The seventh root of 8.
7th root of 8. What's the fancy word with a 3 we could actually use? Cubed root of 8. Okay, if there's no number there at all, what do we call that? Square root of 8. Okay, but if there was a 2 there, what would we still call it? Square root of 8, correct? No number there still means it's a 2 because we multiply something twice to get 8, right? Is there a number that we multiply twice to get 8? What? There is, but do you know it? Can you do it without a calculator? Is it a perfect square, I guess is what I'm saying? No. Okay. What's the perfect cubed root of 8 right here? 2, because 2 times 2, how many different times equals 8? 3, hence the cube there. You got to multiply it not twice now, but 3 times. Yes, we remember that? We got that? So what's the cubed root of 1? Because 1 times 1 times 1 equals 1. What's the cubed root of 27? Because 3 times 3 times 3 equals 27. And the cube root of 64? 4. We understand what the cubed root, oh, that doesn't say. That's not right. It doesn't say cube there. What's the answer to that one? 8. But if it was a third, it would be 4 like y'all said. Okay. Yes, we understand cubed root. All right. Next thing we learned was this little exponent rules here. Actually, we're learning this one first. Let's go to this one. What did we say the number 1 rule was with exponents when they're negative? Can you have a negative exponent? No. So this problem right here, we would change to what, Caden, in order to make that a positive exponent? To the 3rd power, do we put anything on the bottom?
No.
It's moved to the top to make it positive. Okay, so this one, Morgan, 3 to the negative 5. How do we change that to a positive exponent? What, 1 over 3 to the what? Why not negative? Because we got to get rid of it. And lastly, RJ, make this one right yonder. On top, does anything need to go underneath it? Huh? No. Boom, we're done. We got it. Can we have a negative exponent? No, we flip it. Now, sometimes you found out yesterday on IXL, they say, hey, leave it as a negative, right? Or change it to a negative. So just to make sure you know how to do it, they may say, hey, leave it as a negative or make it a negative. But we understand that if we're doing a problem and they want us to find an answer, we are making all negative exponents positive before we write our final answer down. Okay, so then we got into doing some actual math. If we have two numbers with exponents on it, and they have to be exactly the same, they're both a's here, what was our rule to do with those 2 exponents? I add them. So I do a 3 plus a 4, which would give me a to the what in this case? 7. Boom, that would be my answer. What? You ain't never multiplied the 3 and the 4 together. Yeah. When there's times right here, you never multiply. It's a different rule.
He did the wrong IXLs.
He did the wrong IXL.
He did V7.
V7 is multiplying because it's a different rule. Okay, now let's get down to this one. Does the rules change? No. What do I do to the exponents? What? It's timing. So what do? Add 6 plus a negative 4, which ends up, yeah, subtracting, but you add them. What does a 6 plus a negative 4 give you? 2. So what would that be? 9 to the 2nd power? 3 to the 2nd power? 3 to the 2nd power. Do I times those 2 numbers together? No, you keep that base number the same. Don't change it. Okay, so this one, times, do I add those exponents together there? Can I do anything to simplify that problem right there? Say no.
No.
Why?
Because it's not the same number.
Those base numbers aren't the same. These rules that we're learning only apply if these base numbers are the
Same.
same. If that's not true, none of these rules that we're doing, none of this stuff that we're doing matters. Got it? All right. So the first thing we're going to learn today, lesson 1, I'm recording, good, is we're going to now have, you can write, let's write a couple of these down in our notes. Okay. Fractional, what do they call this in your, on your, oh yeah, fractional exponents is what they call it. Fractional exponents is the very last thing on your, what's this thing called? Your cheat sheet that you got. That's the very last thing on cheat sheet, but we're going to take a few notes on it here. Let's have A to the one that have no glue. You ain't bought it yet. Why do they call this fractional exponents?
Because it's a fraction on the exponent.
Wow. Okay. You'll notice on your little sheet, fractional exponents are the exact same thing as roots. Squared roots, cubed roots, fourth roots, fifth roots, they're roots. Okay. And whatever this number on the bottom is, tells you what root it is. So you could rewrite that problem as the square root of A. Boom. You'd put the 2 there if you wanted to. That bottom number is your root. But on a square root, do you necessarily have to put the 2 there? No. Okay. Those two things are the same thing. That's all that is. That's all I'm telling you. That's all I'm saying. Okay. If you have a fraction as an exponent, it's really just a square root or a cubed root. That makes sense? You hearing me? If you have a fractional exponent, it's really just a root. So what if I had this one? A to the 1/3. That would be root A, the cubed root. So what would have to go in front? A 3. Okay. If I had 6 to the 1/4. My base number 6 is inside the root. And what would be my root? 4. We got that? Here's the one thing that blew last hour's mind, or they didn't blow their mind, it was tough on them. Okay. So we had this problem right here. Let's just say it's the square root of 4 here. Okay. There's no number out in front. And then they said to work backwards and make that a fractional exponent. So, okay, I put 4 there. 1 goes on top. What would be that bottom number? But there's not a number there. If it's not a number, it's always the squared root, correct? So make sure you see that and understand that. Okay. No number means it's a 2. Squared means what number? 2. Okay. So getting a little more fancy, couple more examples right here, just fancy ones. Make sure you write these down. If you didn't write those, these are more way, would be just as good or better to write down. Let's go. Let's go 6 to the 3/4. There's no 1 up top anymore, right?
Yeah.
Well, same thing. Let's follow your rules. It's 6. The root's going to be what? 4. Okay. And then that becomes your exponent now. So you're raising that to the 3rd power. Okay. Throw some parentheses in there and go. That's how I would like you to write it. It's not wrong if you wrote it with the 3 inside with the 6. Okay, but I'd rather you throw it with parentheses. Either way is correct. Okay, but do we understand the top number is just our normal exponent where a normal exponent would go? Yay? All right, so try this one real quick on your own. 4 to the 3rd. 8, 4 to the 3rd. Which number is your root, the top one or the bottom one? We got it. It's really not rocket science. Okay. I'm not done there because there's a 4. So the 4 out there in front. Okay. Again, I'll give you options, let you choose your life. You could write it like that if you wanted to. Questions? All right, do one of these just so we make sure we understand what if we got to go backwards too. So if they give you this, 6 square root of 7 to the 4th, write that as the fractional exponent real quick. If you can do that, you can do anything. What's your top number?
4,
What's your bottom number?
7.
7. Make sure you're not writing so ugly that doesn't look like an exponent. Don't write 6 and 4/7 and it make it look like a mixed number or something like you did back in 4th grade. Okay, make sure that's literally an exponent up there and it looks pretty. Yeah. All right, so you're doing page 1, the front of this page, and only the front of this page. Start. Should have, you just think about 9 minutes, 31 seconds to do it. Pass that over to that guy. Only do the side of the boxes if you got it backwards. There's 1 through 12 and then there's boxes on the bottom. That's the side I want you to do. 1 through 12 with the boxes on the bottom. The boxes you're gonna actually write a name to them. The rest of them, that's what I showed you. Number 7 is the square root of what? What root we putting up there?
2.
2. Do we have to put the 2?
Yes. Or not.
Not a 2. We don't have to. If you want to, you could. Okay. And the top number is a 1. Do you have to put the 1 up there?
No.
No. So you could have wrote it like that. That's the exact same thing. Do I need to do another one?
No.
Ask. If you want to do another one, I'll do it. Bottom number is your root. Bottom is your root. So that's the bottom of the other. What number is that? How do you say that? Square root, which represents what number? Yeah, but what number is that? Square is what number? That's a 4th root or something. Square. If you ask, if you don't have a number there, it's what times itself, right? What times what? 2 times? Okay. Yeah. What number is in front of there? Square root. So what number does the square root represent? Square. Right.
What do we do on the boxes?
Found the answer.
So we just write these things.
Oh, find the answer. Square root of 4.
Oh, okay.
times what times what? Fine, yeah.
It's just not. Square root is a two. Because that's how it is. Yeah, let's see what you. You actually saw it.
Got number three, what you got in there?
No, we're not allowed to use calculator. It's just, so this is a square root of 4. Whatever goes into 4.
What about that?
Negative 2 times negative 2 is negative 4, and then negative 4 times negative 2. It's cube root, so whatever goes into it 3 times. It's a cube root, right? The 2 goes into 8, 4. And so it's negative 2 times negative 2, that's negative 4. And then positive 4 times negative 2 is negative.
Oh, it's whatever goes.
Those square roots. Oh, that. I made it square root. Seem to have about a couple more minutes.
So the missing is 3, right?
Yeah. Nope, it's negative 2.
Yeah.
4 times negative 2.
You gotta put like a circle dots or those dots.
Those were easy.
They're not all the same.
You talking about this thing are
All the numbers are not the same.
not every single number is story.
On this or this one, you can't have 2 that are both negative, so it makes the positive and 2 positive.
Probably the answer to that's I. I know.
So what do you want me to put?
Put 4 kind of right.
Okay.
But I kind of right.
4 times 2.
No,
It's what?
these are fractions and these are.
How do you do that?
And when you turn them into fractions,
Aaron, how do you do that one if it's a negative 4?
He said just put. Because it's on here for 2.
All right, in the boxes, in the boxes, in the boxes, in the boxes, I said it. I literally wanted you to write the answer also. So the square root of 4, yeah, you're right, 1/4, cool. You don't even have to write that in the box if you don't want to. Tell me, what is the square root of 4? 2, so you're right. Oh, no, where I went, but. Oh, it's gone now. Square root of 4 actually equals 2, so write that actual answer, just the ones in the box, write the actual answer down also. Yes. Huh? You don't have to, I just want the answer in the box. No answer is bigger than 5.
Second side and the first pattern is, they're the same thing.
Both sides have the same numbers.
Look, you turn this into one of these, it's the same problem as this. Suck it. Listen.
You said they're the exact same. Oh, you said no people going.
Yeah, 'cause they are the exact same.
We going off.
They're not the exact.
No, did you think I meant like every single thing?
Well, you have no comment. Everything's the exact same.
I mean, the thing is,
You make
let's get
it.
to
How would you find 81 to 4?
What times what times what times what?
3, yes. Yes, 3.
On what?
3 times 3, 81.
This?
Oh, yeah.
9,
81.
But it said no, you said no bigger than
3 times 3 is 9. 3 times 3 is 9. Yes, and 27 is what? 27 is 81.
If you change these, they all match up.
You know?
So if you change this one into like into these equations, it'd be.
Okay. That's the same thing.
All right, we'll do the back tomorrow Monday.
If you do,
Get out your notes. Round 2, round 2, round 2, round 2, round 2. First thing I want you to look at is your little cheat sheet here. Okay, you will see this multiple times today on your IXL, the 0 exponent rule. Okay, look here, they have an exponent of 0. What does it say the answer is when your exponent is 0? The answer is what? The answer is what? That rule is vitally important. So if I say, or if I do a bunch of math and I get a to the 0, what does that equal? Did I say that equals a to the 1? No, it equals literally the number what?
1.
Okay, so what if I have, what's this answer then? I'm gonna trick you. What's that equal?
1.
I got some people, it's not 3. Anything to the 0 power is
1.
literally 1. Is it 3 to the 1? No, it is literally what? 1. Yes, we got that? Okay, so what if it's 471 to the 0 power? That equals,
1.
okay, what is 147 to the 1 power equal?
147.
147. So a 0 power equals what?
1.
Don't forget that. That blows people's minds. Okay, you got notes on it that shows it, do you not?
yes.
Okay. Quotient rule. Yesterday with multiplication, we added quotient. First of all, means to do what? What kind of math I guess is that? I guess I should say. It's division math. On your rule sheet here, it literally says a to the x divided by a to the y. And what does it say when we do to those exponents? Subtract. You'll never see it. Well, I won't say never. You'll hardly ever see a divide problem like this with exponents. The majority of the time, you see it like I have written, and you need to write these down in your notes if you haven't already, if you haven't started. Okay, we're going to write these 3 problems down in our notes. So would you agree, even though it literally doesn't have a divide sign, these fraction bars also mean to divide, correct? So our rule is, if my base numbers are the same, they are in this case, what do I do to those exponents? Subtract. And I highly recommend, if you didn't already on your adding, you write those numbers down and literally where you can literally see it, because you don't get to use a calculator. Literally look at the numbers 4 minus 3 and tell me what that answer is. So my answer is y to the first power, or y to the 1. You have to write the 1 as an exponent. You could just write it as y. Okay. Second problem, is it any different? Do we still subtract? Our base numbers are the same, we subtract. This is why I say write the numbers out. -5 and a -3 pops out a what? -8. Okay, unless they specifically told us to leave it at the negative exponent, is that how we would write our final answer? We'd put it 1 over what? Y to the 8th power. Division. When we're dividing two numbers with exponents, what do we do to those exponents? Subtract. What if they're regular odd numbers? Do we do anything different? No. So we leave the 3 as is. We don't go 3 divided by 3 and get 1. They both have exponents. We leave the 3 as is, just like multiplication. And we do 8 minus a -2, which gives you 10. You see why it's pretty important to write out those numbers, especially with subtraction? Okay. And your V6, you're going to have 8,000 different numbers and letters to be messing with. So if you don't have a piece of scrap paper out trying to do this, you're going to miss a whole lot more than you should. Okay. When you're doing these. Exponents and division, what do you do to them? Got it? Let's do a couple examples real quick from my Excel. What do I do to those exponents since it's division? What? Let me zoom in here. -2 minus what? -2 minus the -3 pops out of what? Positive what? 1. You see how writing it out is pretty daggum important. Got it? That would be -2 what? Pops out of what? +5. Writing it out is pretty daggum important. My 7th graders can do that math without a calculator. You ought to be able to do math like that without a calculator. Write it out and get it right every single time. Don't spend 8 hours doing it because you can't, because you're trying to do it in your head. Okay? So here's the hard part today. It's D6. It's combining your multiplication and your division. Okay? The first thing you're going to do when you have both, you see that you have both? Is you're going to combine everything that's together. So if you have two things that are on the bottom together, you're going to do that first before you do the division part. Okay? So since that's timesing, what do I do to those two exponents? And 8 and 5 give you what? So I have 13 J's on the bottom, and I still have 6 J's on the bottom, on the top. So now that I combine those J's, the only thing left to do is what to those exponents? Subtract. 6 minus 13 gives you a J to the -7. And in this case, they say, hey, write this as a positive exponent. So how would I write that? 1 over J to the 7th power. Okay. Everything would be what here? What would I do to all those exponents here? Add them. 2 and 7, 9. 9 and a -5 give me a H to the +4. Give me one more division. Double timer. Give me a double timer. Dadgummit. S to the 16. Give me a both, give me a both, so we see a couple of these, come on, perfect. So what would I do first here?
Add the bottom.
Add the bottom, add the stuff that is together on the bottom. A -1 and a -8 give me a, so I have a -9 on the bottom. Oops, I put 8 and a 1. Okay, now it's a division problem. So what do I do to those two exponents? -1, do the top first. That's a good, I'm glad somebody said that. Always do the top number minus the bottom number. -1 minus -9, which pops out a +8. Top number first. Everybody hear that?
Yep.
Glad someone said that. I would have screwed that up. All right, let's go to the last thing. Last thing is the easiest one. So your V6 is going to take you the longest today. V9 or V7 is going to take you not long at all. We need to go there. Oops, I was there. And then we need to go here. Power rule. This is old Carson's. Told me the times. They told me the times. So you're supposed to times. Okay. On your little cheat sheet, it's the power rule. And it tells you to do what, Carson? Times. Hey, it makes sense though. Look, there's a number and then a parentheses and then another number. Anytime you have a number, two numbers with a parentheses in between it, what's it always been your entire math career? Times. You got two exponents, one inside, one outside. You times those exponents. So what would that answer be? X to the 12. Boom, easy peasy. What would the next one be? X to the -12, but we wouldn't write it like that. We'd write it as 1 over. Boom, easy peasy. Is it the same with regular numbers?
Yes.
So that would be -4 and a -2 pops out of. Do we need to flip that one? Got it. Yeah? Pretty cool. Okay, here's the only exception here. Here's what we're gonna get wrong. Here's what we're gonna get wrong. So focus. Come on, disappear, dude, so I can hook them up. Great, awesome. What's different here? There's two. Okay, it's just like this. I get not just like it's similar to the distributor property. You don't just times that 6 by that number that's touching it. That 6 is going to be multiplied by every exponent that is inside. You hear that and got that? Don't forget to also multiply that 6 by that 3. Okay, so if I do that, how many U's do I have? -3 and a -6 times those gives you +18. And my V's are 11 and 6. Or that'll give me a positive what? That makes sense? Every number inside, yes? That one would be easy. G to the -88. All right, last one. This one is what it's going to get you. We have a G and an X to the 4th to the 3rd power. You got to time that 3 by every exponent, right? There's 2 letters, so there is an exponent on that G, even though you can't see it. What is the exponent on that G? Don't forget that, okay? Don't forget that 1 there. So how many G's would there actually be if you times that 3 by both of those? 3 G's and how many X's? 12. There you go. B5, B6, B7, due Monday. If you really get working, you'll get really close to getting done today. Yeah, keep that page we did today. We'll do it Monday. Do the backside Monday.
Is that all y'all do?
Yeah.
Tuesday, Wednesday, and Thursday?
No. No. We took a test. You got a test on no later than Tuesday. You got to set a time before.